But thanks to currying and how simple partial function application is in Haskell, we can actually get rid of this args variable and get the same effect with this here. And welcome back to another episode of Haskell from Scratch, where we are continuing our slow and steady progress towards a working implementation of redo. In the last episode, we added the functionality to have a default do file for when you have multiple targets of the same type, distinguished by a file extension. But we weren't able to test this because we were missing another part of our implementation, and that is passing along some information about the target to these default files. Otherwise, we won't know what the target is. In this case, we were trying to build a README file, but since this is a default do file, we don't know what the file name is. So let's take a look back at the code for redo.hs and go ahead and add this in before we do any cleanup and refactoring, because I'd like to make sure that the code works before we change it in case we introduce any errors during the refactoring. So essentially what we need to do is make use of these other arguments we have here. We're using a third argument to the script, and that is the temporary file name to write any result out to if you're not using standard out. And these first two here, we've just put a dash in for now, but it's time to look at what these are for. If we look back at the paper with the implementation in shell script, there is a line here that you can see. It's actually broken out into two lines that shows which arguments get passed in. So the second argument here is the base name of the target we're building, and the first argument is 0, which is a little bit strange. Now, there is another implementation of redo that uses this first argument to pass in the complete target name, and supposedly is based on the actual implementation or a prototype by DJB. But if we look at what's going on here, it may make sense that this first argument isn't used in this paper. Just so you can visualize what I'm talking about a little bit better, let's go back to the shell. And so we're going to be calling our default do script here, and right now we're passing it arguments like this. The target name is going to be readme.text redoing, or rather at least the temporary file is. And we're going to want to pass in the base name here of readme. Now we could also pass in the target name readme.text, but for a default file we can already guess at what that extension is going to be because the default do file is written in terms of extensions. And in the specific case, we don't need that information either, or at least we shouldn't. Also, passing in this first argument is a temptation to actually use it, which would break the atomic operation of redo. So, for example, if someone were to use this to write out to that file, there could be a problem when the temporary file is moved over top of it. So we're just going to use 0 for now. So let's look back at the code and go ahead and implement this. And it should be pretty easy. Let's change this first dash to a 0, close the string here, and this next part, we're going to need spaces around it, is going to be the take base name of the target. We're going to need to import take base name. So let's try compiling that. Redo. And now we should be able to test our default.text.do, but let's go ahead and say that we want a plain text output, and we're going to use the second argument to locate the markdown based on the target name. So let's give that a try. So we're going to rebuild readme.txt. Oh, and I haven't installed Pandoc here, so I'm going to do that really quickly and be right back. Okay, so now that Pandoc is installed, let's give that another try. And we end up with a readme.txt file here that almost looks like Markdown, but it's not. We can take a look at the difference between them here in Emacs. Let's take a look at the readme.markdown. So it looks like the implementation of default do files is working correctly, and instead of testing that any further right now, I'm going to make good on my promise of showing you how we can refactor the code a little bit, especially after introducing some of the ugliness here with monads. Now to start with, I'm actually going to take the main function and show you, if you haven't seen monads without do notation yet, what this would look like. Basically, we would have get args and bind that to the args variable, and then map m redo over the args. So let's try compiling that to make sure that it works, or at least compiles, which should be the same here. And so this really hasn't improved anything. We still have this variable name here, args, and we've put things on one line, but there's really the same density of information. But thanks to currying and how simple partial function application is in Haskell, we can actually get rid of this args variable and get the same effect with this here. So get args will pass its result through bind to map m redo, which is, as you recall, map m is a function with two arguments, but really everything in Haskell is a function applied to one argument that produces a function that may take an argument after that. And I'm sure you've seen that in some tutorials or blog posts around the internet already. So this is actually looking a little bit simpler. We can also rewrite this by moving the get args onto this side and compiling this. And I like this form a little bit better because it almost looks like, if you ignore the bind operator, or the reverse bind operator here, it almost looks like a simple function application. So let's take what we did here with main and see what we can do with redo path. So one of the things I was complaining about earlier is this existing candidate's name. It's kind of a name I came up with in a hurry. It's repeated a couple places, but really it's just being used to shuttle a value from one part of monadic action to the next. And we just saw a way of eliminating that. So let's see if we wrote this the same way. And we put the safe head over here and got rid of these. This would seem to do the trick, but we're going to hit an error here. And couldn't match type maybe with IO. Well, this error message may or may not make sense to you, but I'm going to explain what's happening here. This safe head is not an action in the IO monad, and bind requires the second argument, or in this case the first, since it's reversed, to have a monadic type that matches that of the entire expression. So what we need to do is bring in something from control monad called lift m, and you might be seeing a pattern here with map m, filter m, lift m, and so on. And we're going to lift safe head into an action in the IO monad. So you can see from the type signature here that it takes a function from A to B and turns it into a monadic function, or rather a function that takes monad A and returns monad B. So this will lift safe head into the IO monad, but we're still not done. This isn't going to compile yet because bind wants a function with a non-monadic value to a monadic one. So what we really want to do here is just normal application. And this works, but it's actually more common and more idiomatic to see lift m used as a operator. And so you can see that this does the same. And when you put lift m into this position, it looks a lot as if you had the reverse bind operator there. So this is good. We've eliminated some unnecessary variable names, args, and existing candidates. The code is on fewer lines, and I think easier to read as well. Now let's take a look at the redo function and see if there's anything we can do similar here. And the first thing that jumps out to me is this maybe path here, which is really just a name for something just to check in a moment if it's nothing or just a value. So one way you could try approaching this is using the fact that maybe is a monad and try binding the action we want to take in the case of just a value, but it turns out that's a little bit complicated, especially because we're already dealing with the IO monad. So let's just play with this a little bit. I don't have a perfect idea of what we're going to do with it, so I'm just going to copy this code here and comment it out so that we can look at it as we go. And my goal is to eliminate this maybe path name. And the reason it's necessary here is that case we can't say redo path target here in the case because case doesn't handle monads in that way. We have to first store the result of redo path in a variable and then use it here in the case. And I'm using the word variable here just for lack of a better term. These obviously aren't variables in the sense of an imperative program. They're just labels for a value. But what we could try to do is get rid of the case altogether. So one way of doing that is trying to use a bind here like before. And we can use the function maybe, which takes a default value, a function to apply if the value is just. The default value gets used if the value is nothing, which is the third argument here, and it gives you a result. So in the default case, we'd have this error here. And in the case of a just value, we would have this monadic action. So let's put this in here and let's see if it compiles. It looks really ugly, I know. And we're going to get the path in as an argument. And this works. We've gotten rid of that maybe path variable, but it's arguable that this is even uglier to look at than what we had before. And I think some of the main ugliness here is that we have this giant monadic do block in parentheses here. So why don't we just give this a name? We'll just call it something like redo prime and move it into a where clause. So we'll have where redo prime, which takes a path, equals this bit here. Let's fix up the formatting a little bit. Great. Need to take off that close parentheses. And so let's try compiling that. Oops, and there's a parse error, and that's because my indentation is not correct. Not based on the where, it's based on the, oops, messed up that keyboard macro. Okay. So let's try this again. And temp is not in scope. So what we have here is the name that we bound in a let is not available in a where. So let's move that into the where clause and try this again. Oops, I think I'm off a space there. Okay, and so that compiles. And we've managed to get rid of the name maybe path, but we've introduced redo prime in the process. So it seems like we really didn't gain anything here. But we do have the ability now to put a type signature on redo prime. So it's a file, it takes a file path and returns nothing in the IO monad. And depending on who you ask, this may be easier to read because you can read this first term here separately from the monadic action that we're going to run in the case that we have a valid candidate path. And maybe we can make this a little bit clearer by saying, maybe no path, and the error is called in that case. So no path here would be this. And we can compile that. And we can also get rid of this do here since we just have a single line. And so now it reads to me pretty clearly that maybe there's no path. Actually, that's a bad name for it. Maybe just print missing or something like that, because that's really what this is doing here. So maybe we print missing if there's no redo path for the target, or we run redo prime here, which is defined below here without checking for any maybes, because it always receives a file path. So you might argue that this is less clear than the other. I'm going to go ahead and remove the old version here and just stick with this one for now, because I think that not having as much indentation is a virtue in and of itself. I've written a lot of functions where the amount of indenting through checking things with cases can get a little bit confusing and excessive. And I'd rather have things broken out into different definitions in a where clause than have a bunch of nested cases. So this function still isn't perfectly clear, and I'm looking at this line here with shell, which is a little bit ugly. So what we could do is break this out into another where definition called command, and it is going to be this. So let's give that a try. Oh, and path is not in scope because, again, the where clause has access to any of the function's arguments, but it won't have access to this function's argument, which is in another where declaration. So we can just pass that here. Okay. And I'm still not perfectly happy with how command is defined, because it's a little confusing and error prone to have to deal with padding all of the arguments with spaces here. So I'm going to change this to use unwords, which let's take a look at in GHC what words does. So words takes a string like this and converts it into a list of the words separated by spaces. And then unwords does the opposite. So we can go ahead and convert this into a list and not worry as much about the spaces here, because unwords will do that for us. And I think it's a little clearer and easier to understand. So let's make sure it compiles. And then just in case you want to see what this result looks like here. Oh, I can't put this into GHCI because there are variables that won't be in scope at the top level. But what we could do is, in the next episode, take a look at using debug.trace to actually trace what this is, so that we can make sure that the shell command is accurate and that we're not just relying on faith here for this. So to me, this function looks pretty good. I don't know what else I could do to make it any simpler or easier to read, but maybe you see something and would like to leave a comment on how to improve this. I'd really appreciate it if you did. But I don't think we are fully done here with cleaning the code. There's a few more things we can do. One of them is that safehead really isn't specific to redo path. We can use it anywhere we want. We should really take it out of this where clause, and while we're at it, we might as well add a type signature. And so safehead can work on a list of any type, and it returns a maybe of that type. So let's try compiling that. And it seems strange that safehead doesn't already exist for us. So why don't we try looking for it with Haskell in GHCI. So we'll search for the type. We have the type signature here already. It's from a list of A to maybe A. And the problem is that, in my experience at least, Haskell's search based on types is very lenient and returns a lot of results. And you could try something like, if you search for something with head in the name with this type, it'll give you some fewer results, but still not what we're looking for. The type signature, there's no exact match here. So what I'm going to do instead is, from the shell, I'm going to run Haskell with this search. And I'm just going to look at the first results in case there's anything there with head. And you could make this into another alias or change your GHCI file to only return a certain number of results if you want. And I might do that in the future, but for now this gets the job done. And we can see that the first result here is list to maybe, which looks promising because it has the right type signature. So let's try it out in GHCI. Let's use list to maybe on the list 1, 2, 3. Yeah, it's not in scope. It's part of data.maybe. It returns just 1. On the empty list, it returns nothing. And yeah, I think that's really all we need to do to test that. So we can use data.maybe list to maybe in the place of, in the place of safe head here. List to maybe. Get rid of safe head and try compiling our program again. And so now we've reduced the number of lines of code here by a little bit, but I think more importantly, we've gotten rid of a couple temporary names that we really didn't need and broke out this redo function a little bit more into separate where clauses. And so we have less code, more features, and hopefully more readable, which is a result I always like. Actually, we can do one more thing here while I'm looking at it just to improve readability. We can break this if then else onto multiple lines. Compile that again. And there you have it. Now our implementation supports handling default do files. And in the next episode, aside from showing you the Debug Trace module, we'll go ahead and extend the features again, perhaps adding support for actually testing if we even need to rebuild the file. But we'll see what is the most natural thing to add next. Again, if you see something I'm missing here that can make the code even simpler and easier to read, I'd love to see a comment. Thanks for watching, and I'll see you next time.